Let's interrupt the footage right here for a second and do a flyout in Google Earth. It's an approximate location along the flight path. Actually, we had crossed Colorado River. But anyway, this works to illustrate just the curvature of the Earth that we should be seeing. Have a look at how it looks, how the land just appeared from that horizon. You can definitely tell there's curvature due to the aspect ratio, and also a little bit of curvature in the transverse or x-axis direction. Very interesting. I have to scroll here quite a bit to get out to the mountains. This is Navajo Nation land. Here we go. And now we're approaching the 14,000 foot mountains of Colorado. Here's a map illustrating the flight path from Los Angeles. Along the flight path, we determine lines of bearing towards the mountains that I see in the distance. That's how I can tell what I'm seeing. Take special note of Humphrey's Peak. It's a great point of reference. If we were living on a globe, a sphere, the mountains in Colorado should not be visible. They're only 14,000 feet, and at that distance, the curvature would be hiding them. Flying at 30,000 feet, we should be looking down towards a tangential point to the sphere at about 3.1 degrees relative to our perceived horizon, or 90 degrees to the gravity vector. I was able to use in-flight theodolites to determine that that also is not correct, indicating the Earth is really flat. This graphic captures what I've learned so far from my infrared imaging from high altitude. The atmosphere prevents seeing at shallow angles. There's a critical angle beyond which the light rays just bend as they enter the warmer regions of the atmosphere with more moisture content. So we cannot see way in the distance. There is a limiting factor. As you can see in the inset, using my theodolite app, I determined where those angles were, and you can see that where the spherical Earth horizon, the theoretical, should be, we can obviously see above it. And at about 1.9 degrees, it seems like we can't see anymore because of the haze. But if we look at the surface that we're seeing, it doesn't curve out of view. If that were the horizon, it wouldn't look like that, We would be looking at a zero grazing angle. As you watch the video, keep these images in mind. I've extracted what the mountains look like along those lines of bearing we saw on the map. So be on the lookout for these. I will try to narrate and point them out. Initially, I did not see the mountains at 500 miles. I thought they were clouds. I only noticed them around 480 miles when I was looking at Humphrey's Peak. That's when I noticed those pale, what looked to me like clouds. And then later I noticed what they were. Now here's the shocking conclusion, folks. We're seeing those mountains in the distance at the correct elevation for a flat Earth. Just incredible. Not only should we not be seeing those mountains if we lived on a sphere, but we're seeing them, and we're seeing them at the correct elevation for the shallow observational angles, which are about 0.38 degrees to those distant mountains and about 0.9 to Humphrey's Peak. Simply incredible. The Earth appears to be astonishingly flat.